Welcome to AP Podcast 11.1. This is Chapter 11 stuff, and it's all on solutions. And you know what a few solutions are. We've looked at them, we've mixed them, and all that. And so let's get to a little more detail on exactly what they are. Right? Now, solutions are made of two components. There is the solvent, that is the thing that does the dissolving, and typically for us, the solvent is going to be water. Other things can dissolve compounds, but for us, most of the time, the solvent that we're talking about is going to be water. The solute is the thing that gets dissolved. Now, it's most commonly to think of a solute as something solid. For example, if we were going to make a solution of salt water, the solute would be salt, and of course it's crystalline form, and then the solvent would be water. So it's most common, at least for us, to have solutes in a powder form, but it's going to happen in a number of our problems where we're going to take a solute that's in a liquid form and dissolve it in another liquid. And so that's going to be very common to our problems. And also you can definitely have a gas situation where you've got a gas dissolved in another gas. It's not just one specific phase. But the important thing is to keep track of the fact that the solvent is the thing that's doing the dissolving. And I can't really think of too many examples, but almost always the solvent is going to be the component that is in the greater amount. So this is in the greater amount. Now, don't quote me on that for everything, but for the most part, our solutions, the solvent is the thing that's going to be in the larger component. All right. So what we're going to focus on, because we use them the most, are aqueous solutions. And all the solutions we use in class, if you think about them, they are a homogeneous mixture. In other words, when you look at any solution we've used in class, most of them are clear, a few of them are colored, but they're definitely not heterogeneous where you see some different chunks. They're all going to be a homogeneous mixture, and we're talking about aqueous solutions, which means they're dissolved in water. So let's look at some of the math that you can do with these, because there's a lot of different ways to represent the concentration or the composition of a solution. And so here are four of them right here. You're familiar with one. We've seen molarity. This is the big M that's on every solution we have. And it's simply the moles of the solute divided by the liter of solution. All right, so that's one we're used to. Mass percent, and this is by mass, so it's the mass of the solute, the thing that gets dissolved, by the mass of the solution. And when we're talking about, I'm trying to think of a real life example, and maybe this is inappropriate, but alcohols are usually the ones that I can think of when they say that beer is 6% alcohol, or wine is 12% alcohol, or hard liquor is 40% alcohol. They're talking about by mass of the solute divided by the mass of solution. Here's mole fraction. We've seen mole fraction already when we were talking about gases and we were doing some gas law problems. But again, now it says mole fraction of A, so we're just talking about whatever, usually it's going to be the mole fraction of the solute, okay, divided by the total moles. Calculating the same way. This is not going to have a unit, all right? And mass percent is also not going to have a unit. Here's the unit for molarity. And then the last one is molality. And we're going to use molality a lot at the end of this chapter when we do freezing point depression and boiling point elevation. But molality is the moles of the solute. So again, it's very much like that. But here's the big change. Look at this. Kilograms of solvent. And this I want to focus on because I can't tell you how important this one is. Because look at all the other ones. Look at here. We're talking about total moles. So that's the solution. Total mass of the solution and liters of the solution. So you really got to remind yourself that when we're dealing with molality, it's divided by the solvent. And again, I'll show you a few of those stumbling blocks when we do some problems. So there's our basic 4 math problems that we're going to be doing when calculating the concentration of these. And what's kind of fun is they'll give you one of the 4, and then they'll make you find the other one. Now, when I say it's kind of fun, some of you are probably rolling your eyes, but the way I'm looking at it is it's like a puzzle. So let's try one of these problems, and I'm going to work out the math, and then, we'll see how it goes. So here we've got some antifreeze solution, aqueous, which means dissolved in water, and it's 40 ethylene glycol by mass. And then it gives us a density, and then look what it wants us to calculate. Calculate the molality, molarity, and the mole fraction. All right. So this is what I'm going to do to start this problem. I'm going to kind of just figure out, well, what's 40% by mass mean? Well, that means ethylene glycol is 40 grams, right? I'm going to make it easy. And I'm going to say I have 100 grams of the solution. Okay, SLN. All right, so that's the solution. So I'm going to say I have 100 grams of solution, and 40 grams of that will be ethylene glycol. Well, which one of these you calculate for first, molality, molarity, and mole fraction, really kind of depends upon your preference. You can find any one of these at this point, but I like to go through a certain part, and so I'm just going to show you the way I would do it. The first one I'm going to find is mole fraction, because I know I can change these into moles. So I'm going to take my 40 grams of ethylene glycol, EG, right? And I'm going to find the number of moles that is. Well, 1 mole of that happens to weigh 62.07 grams. And that gives me 0.644 moles of ethylene glycol. All right? So again, if I look back to the slide before, if I look back to the slide before, I've got the moles of the solute up here, right? But I need to get liters of the moles of the solute. I need the total moles. So I've got my moles of that. I need to get my moles of water. Okay. Well, what do I have here? If I have 100 grams of solution and I know 40 grams of that is ethylene glycol, I must therefore have 60 grams of H2O. Hopefully that makes sense. 40 grams of that plus 60 grams of water gives me 100 grams of solution. So again, I'm going to find the moles of water. 1 mole of water happens to weigh 18.01 grams. All right, and when I calculate that out, I get 3.33 moles. All right, so then to get the mole fraction, I'll just put a chi sign, is my 0.644 moles of ethylene glycol divided by total moles. Now, when I add those two together, I get a total number of moles of 3.976 moles. That's my total, right? So I'm going to put that number right there, 976 moles. And that's going to give me a mole fraction, I'm going to put that answer over here, of 0.162. Okay? Now, like before, that does not have any kind of unit. All right, so I've got my mole fraction. Now what I'm going to do next is I'm going to do my molality. And here's the reason why. Look at this. In molality, I need the moles of solute. I've already calculated that out, right? And what I'm going to need to do is find my kilograms of solvent. So I'm going to erase. I'm going to go to this next slide and erase, and then we'll do the next part. Okay, so I'm going to take my moles of solute, which I have up here, 0.644 moles, and I'm going to divide it by the kilograms of solvent. Now, remember, up here, I had 100 grams of solution, right? Well, if 100 grams of that was a solution, then 60 grams was water. So how many kilograms is that? Well, if I take 60 and divide by 1,000, I get 6.06 kilograms. And when I work that problem out, I get 10.7 molal. All right, so there's that one. Not too bad. So I've gotten molality, I've gotten mole fraction, and the only one that's left is molarity. All right, so with molarity, I need my liters of solution, right? Well, up here I had 100 grams of solution, so I'm going to write that down. Now look what other piece of information they gave me. They gave me the density right there, right? So I'm going to take that density, and I'm going to go 1.05 grams per 1 cubic centimeter. Right? Now I want liters, so I'm going to go 1 cubic centimeter is 1 milliliter, and then 1,000 milliliters is 1 liter. And that I'm going to put right over here, and the answer to that is 0.0 0.0952 liters. Okay, so when I work that out, when I work that problem out right there, I'm going to have to put it up here. Oh, blue's not good at all. I'm going to have to keep it in red, I guess. The answer I get there is 0.0952. Oops, I'm having a brain fart here. 1 second. How about this answer? 6.76 is the molarity. All right? So there you go. Kind of a puzzle. And we're going to do a whole bunch of these so you get really, really good at them. And that's it for this little podcast. Again, if you have questions, we'll go over my math if I made a mistake, which, could happen. And we'll see you next time.